Well, hello again. Okay, so today we're going to talk about expanding binomials, and I'm going to show you two ways to do it. One is long and obnoxious, and the other way is a shortcut. You need to know how to do both because both are going to be on your test tomorrow. Okay, so let's jump right in. So what is a binomial is what you need to know first off. So this is a star. You can make a note card out of it. A binomial. Okay, and this is what I'm going to name it. Okay, for the sake of argument. It is a, bi means two, so it is a two-term expression raised to a power. How big is that in your video? Oh, that's definitely readable. Two-term expression raised to a power. So we've got this, x plus 2 to the fourth power. Okay, this is my binomial, and that's my exponent. Okay, beautiful. So let's talk about what exactly the purpose of this is. I feel like we don't talk about that enough in math. So the purpose of this is, let's say we have a problem where we're trying to figure out what. Let's use that x plus 2 to the fourth power. We're trying to figure out what that is. Okay, we don't really know. Let's talk about what x to the plus 2, let's start here, x plus 2 to the 0 power. Well, anything to the 0 power is 1. Anything. If you raise a banana to the 0 power, you get 1. Okay, let's do x plus 2 to the first power. Well, you get what you raise to the first power, you get x plus 2. Now, as we raise to the second power, we get more complicated. Okay, so we go to, what does this really mean? Well, it means this. It means x plus 2 times x plus 2, right? That's what it means. And to solve it, you just don't do, well, it's x squared plus 4. No, that's what everyone does. It is not that. You must multiply this x times everything, this 2 times everything, okay? So you end up getting a larger term than a simple x plus 2. You get x squared plus 2x plus 4. Okay. That's what you end up getting. I think it's 4x. Sorry. X squared plus 4x plus 4. Okay, that's what you end up getting. So, they get more and more complicated. So if I do to the third power, it's 3 of these sets of parentheses, right? So how do I figure out all the way up to the fourth power, or to the fifth power? I'm going to teach you how to do all the way up to like the 8th power, okay? So you're going to be able to do all of these. And that is the expanding. See how I started with parentheses and I expanded it all the way out? Well, that's what we're going to be doing with very, very large terms. And I'm sure most of you who have been absent have seen this on Facebook where people are talking about how crazy I am for teaching you this, but it's in my curriculum. So, have fun. But you can do this. All of you are smart enough. I believe in you, and we're going to work through it together. So let's talk about what the binomial theorem is. Well, it is the theorem that helps us solve these. So binomial theorem. If that last thing I said about all expanding didn't make sense, watch it again. Ask me a question about it, okay? So binomial theorem, I'm going to give you the formula. So let's say we're trying to solve a plus b to some n, okay? So this could be x plus 2 to the 5th power, or y plus 4 to the 3rd power, okay? So these are just letters representing numbers. The way I solve that is this ugly formula, okay? Sigma n, k equals 0, okay, of n over k times a to the n minus k times b to the k power. Okay, once you write that down. Now let's talk about what this means. Okay, so that's my formula, that's your note card. Now I'm going to tell you what everything is. So my n's, so I've got an n here, in there, right? Whew, sorry. And another n. So all of those represent what? Well, that's my exponent. Exponent. and that n stays the same throughout. Now my k, okay, all of these k's here, all three of them, come from my number that I get here, okay, from that k. All right. Now that's going to eliminate, that's going to go away once we start working these, and it's going to come from this k. So both of these are my k I'm looking at, okay. This k equals 0 is where I start, okay. I start with k equals 0, and I go until k equals n. So k equals n will be n represents what? Exponent. So I go until my k is the same number as my exponent. Right. I know there's a lot going on there. Hopefully it makes sense. We're going to do a problem and work through it together. Oh, something else I need to tell you before I move on. This parenthesis is the most annoying part when you do these by hand. Okay? It's the hardest part, kind of. Okay? These are all combination problems. Okay? Where it is NC, okay. Remember when it was NCR is what we were doing? Well, now we're just replacing the R and putting a K. So this is your total options, and that's what you're choosing when we do the combination problems. We'll get there. I know all this is like French to you right now. Just go with it, write it down, and as we work through it, hopefully it'll make sense to you. Okay. So I'm going to try and leave, I'll just rewrite it. Okay, we're going to work through a problem. And I'm going to write my formula on the board again, so that you can see where I'm getting stuff from. So let's do, I'm trying to think of the best way to explain this. All right, I'm going to do the original formula. So you've got A plus B to the n equals sigma n k equals 0, A to the n minus k times B to the k. All right? Now, it will always be k equals 0 unless some freak problem tells you not to do that. Alright? Now, let's say this is my problem. Expand x plus 2 to the 4th power. Let's do 5th power. To the 5th power. Okay? So now what I'm going to do is I'm going to go through and I'm going to replace all of the letters with the numbers I now have. Okay? So it's still sigma. N is actually what? Well, it's my exponent. So 5 goes on top, still starting at 0. I will always have k equals 0. Oh, I forgot my little parenthesis here. It's n over k. So I have n over k. Okay, my n is 5 over k. We don't know what our k is yet. We're going to get there. Then my first variable, the first thing I'm using, my a, is x, right? So that goes here. X to the n minus k. Well, n once again is my 5 minus k. So all I'm doing is replacing it with the stuff I know. What's my b in this problem? Well, b was here, it goes there. Oh, so b must be 2. So 2, okay, raised to the k power. So this is now the formula I'm going to work with, right? So I took the original formula, I replaced it with stuff I know. Okay, it's going to get really ugly, really fast. So what I actually start manipulating and changing is this guy. And I write that over and over and over again until my n equals my k. Remember I wrote that, and I said that k, whenever k equals n, you stop. So whenever I get 5 over 5 is when I stop. So I start with, how far can you see? Because we're going to need all this room. I start with 5 over 0. Okay. So 5 over my k. My first k, where do I start? I start at 0. So that's where my 0 came from. Times x to the 5 minus, oh, what's k? My k is 0. Okay, I get my k from right here from now on. 5 minus 0, 2 to the 0 power. 2 to the k. 2 to the k, my k is 0. 0, 0, 0, k, 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 right? Ha ha ha, I said KKK. Alright, so that's my first one. Now, since it's a sigma, I do a plus sign. And I'm hopefully writing big enough for you to see. I'm trying to write really big. Okay, now I do my next k. Well, I said I go until k equals my n. So I did 0, and now I keep going. 1. Okay, so I did 0, now I do 1. X to the 5 minus k. 5 minus k. K is 1. Alright. Times 2 to the k power. Well, k is 1. Now I'm done with that one, and I keep going. So my next k will be what? I did 0, I did 1. Oh, let's do 2, right? And I'm running out of room. So I'm going to start writing smaller. So I do x to the 5 minus 2 times 2 to the 2, alright? Plus 5 over 3. And I'm going downhill. Holy cow, real fast. X to the 5 minus 3, 2 to the 3. Can you still see? Yes, you can. Okay, we're going to move down here. Plus, so I did 0, 1, 2, 3. Now I do 4. 5 over 4. X to the 5 minus 4. Still using my k. 2 to the 4. Okay. Plus, what's my last one? 5 over 5. When I get to 5 over 5, when I get to n over k, I stop. Okay. X to the 5 minus 5, 2 to the 5. Now what I want you to see, well, write that down. Hopefully you can get it all in one line, because I'm going to erase it and rewrite it on top. And I know, I said write it down and I'm in your way, but I'm sorry. Okay, and pause now. Okay, hopefully you got it. I'm going to rewrite it up here. Okay, so 5 minus 0, 2 to the 0. Can you see all the way to the top? Yes, you can. Okay, plus... awkward elevator music right now. That's what we need. Yes, you can still sing. Oh, 2. All right, praise the Lord. We've made it. All right, so I'm going to erase this big ugly thing at the bottom. Wow, that is terrible. I cannot write level. Okay, so hopefully you're still tracking with me. I heard you say, I have no idea what I'm doing, Charity. But keep following. Alright, so now I simplify. And there's not a whole lot of simplifying I need to do because everything's here until you get to the combination part. So, but what I'm going to do is this. I don't worry about my parentheses, leave them be. Okay? What is x to the 5 minus 0? Well, what is 5 minus 0? 5. So it's just x to the 5th power. So what I'm going to be doing is I'm getting rid of all these minuses up here. That's my goal right now. And I'm going to get rid of all my zeros. What is anything to the 0 power? Remember I said, what is banana raised to the 0 power? 1. Anything raised to the 0 power is 1. So if all of these are multiplication, right, in between here. So if I'm multiplying by 1, do I need to write that? No, so I just leave it alone. So 2 to the 0 is 1 power, and x times 1 I don't need to write times 1. So I leave it alone. So I go to the next one. Leave my 5 over 1. What is x to the 5 minus 1 going to be? Well, 5 minus 1 is 4, so I guess it's x to the 4th power. And now I leave 2 to the 1st power. What is 2 to the 1st power? Anything to the 1st power, you get itself. So you just get 2, right? Okay, keep going. 5, 2, x to the, why do I write downhill? X to the, what's 5 minus 2? 3. 2 squared. Okay, keep going. 5 over 3. I subtract, I get x squared, and I get 2 to the 3rd power. Alright, plus 5, 4, x to the 3rd power, nope, x to the 1st power, 5 minus 4 is 1, 2 to the 4th. And last but not least, 5 over 5, x to the 0, 2 to the 5th. Now, if x to the 0 power, I need to write that. I didn't write my 2 to the 0, so I don't write my x to the 0. I'll leave him be. I'm going to move 2 to the 5th over. Okay. Beautiful. Now comes the most annoying part of all of this. I told you that these parentheses were something. They were all little bitty problems. What kind of problems were they? They were combination problems. And I told you that it's going to be N, C, K, right? N's the top number, K's the bottom number. N over K. So the formula, I'm going to move this. Hopefully over here. You don't have a whole lot of room to see. So I have, yeah, you can see here, N, C, K. The formula for a combination problem is N factorial over N minus K factorial times K factorial. Write that down. You should have it memorized from last week, but I'm sure you don't. So I'm going to do that for all of these. All right, so let me start with 5, 0. So I have 5C0. Now what I'm doing, okay, and I didn't say this when I taught it the first time. Whatever I get as my answer, so I'm going to get some answer. Whatever I get for that answer replaces this 5 over 0. I'm going to say it again. It replaces the 5 over 0. Okay? These will become your coefficients. I'm going to define that term in a second. Don't let me forget. Okay? So let me solve this and see what I replace this 5 over 0 with. So I do 5 is my N, 0 is my K, and I plug it into this equation. So I do 5 factorial over 5 minus 0 factorial times 0 factorial. Well, 0 factorial, okay, I want you to just treat it as just 1. As if it's not there, okay? It's not there at all. Just forget it, okay? So 5, what's 5 minus 0? 5. So I get 5 factorial over 5 factorial, okay? So what am I going to get before I do all that multiplication? What's anything over itself? It's 1. So this magical answer I get here is 1. Alright? And I'm going to box in all of these so that you can see where they come from. So 1. Now, I do my next problem. So I did 5, I'm going to put a check mark. I did 5 over 0. What am I going to replace that 5 over 0 with? 1, because that's what I got in my answer. This will go here, and I'm going to rewrite it 1, maybe 2 more times, and I'll be done. Okay. Now let me do 5C1. Okay? So I'm doing my next parenthesis. Same exact way, same formula. 5 is my N, 1 is my K. So I do 5 factorial over 5 minus 1 factorial times 1 factorial. What is 1 times everything below it? Well, it's just 1. Okay, so don't worry about your 1. Okay, now I'm going to get 5 factorial over, what's 5 minus 1 factorial? 4 factorial. So 5 factorial is 5, 4, 3, 2, and 1 over 4 factorial, which is 4 times 3 times 2 times 1. Now what do? Cancel out. Everything cancels except for my 5, so that's my answer. So I get 5. Let me put that in a box. So far I've got 1, 5. Okay, I'm going to keep going. So now I've done 5, 1. Now let me do 5, 2. 5C2. And I got to go all the way through. And I know it takes forever, but it's not bad. N, K, 5 factorial. Okay, over, now, I'm going to do this a little shorter. Okay, what's 5 minus 2? I can do that in my head. 5 minus 2 is 3 factorial. And my K is 2 factorial. I want you to see something. Okay, what did I get here? I got 4 and 1, right, and made 5. I got 5 and 0 and made 5. I got 3 and 2, which makes 5. My bottom always adds up to the top. Okay? So now I can solve that. 5 times 4 times 3 times 2 times 1 over, what's 3 factorial? 3 times 2 times 1 times 2 factorial times 2 times 1. Right? Now I'll mark out 1s, 2s, and my 3s. And I get 5 times 4 is 20. 2 times 1 is 2. My magic number is 10. Right? Okay, so now I've got 1, 5, 10. Okay. Wouldn't it be nice if the next one was 15? It's not. Okay, it's not that easy. Now I'll do my next one, 5C3. And I know I'm right in the way. Pause it if you didn't get it. Okay. 5C3. So now I'm doing the same formula. This one right here. 5 over 5 minus 3 times 3. Okay. 5 factorial. What's 5 minus 3? It's 2 factorial times 3 factorial. Once again, what does the bottom do? Add that to be the top. Now, if it's 3 factorial times 2 factorial over here, and then it's 2 factorial times 3 factorial over here, and I just flip-flop them, what do you think my answer is going to be? Well, we're going to find out. 2 times 1 times 3 times 2 times 1. 1s, 2s, 3s, cancel out. I get 20 over 2. Wow, I got the same answer. 1, 5, 10, 10. Okay? Keep going. We got 2 left. Alright? So now I do 5C4. 5 factorial over, what's 5 minus 4? 1 factorial times 4 factorial. Well, wait. I had the same thing over here. I had 5 factorial over 4 factorial times 1 factorial. Okay, so if I flip-flop, what answer should I get? I should get 5. Let's see if we're right. 5 times 4 times 3 times 2 times 1 over 1 times 4 times 3 times 2 times 1. 1s, 2s, 3s, 4s cancel. I got 5 over 1, which is 5. Do you see a pattern yet? 1, 5, 10, 10, 5. I went up, and now I'm coming back down. So what do you think my last one's going to be? 1, 5, 10, 10, 5, 1. Alright, so plug in my equation. 5 factorial over 5 minus 5 is 0 factorial. Told you not to worry about it. Times 5 factorial. So I get 5 over 5. Anything over itself is 1. Okay, so I've done all my parentheses now. 1, 5, 10, 10, 5, 1. That's what I get. 1, 5, 10, 10, 5, 1. Isn't that beautiful? So now what I do is I told you that these numbers do what? What is the purpose of them? They replace all of my parentheses. Okay? So I'm going to erase that. Okay, I'm going to remember my order. 1, 5, 10, 10, 5, 1. Yes, I have that memorized for doing this. It's the same problem over and over again. Okay, so 1, 5, 10, 10, 5, 1. So I replace that. Okay? 1 times x to the 5th. Right? Plus, what was here? I'm going to write them above instead of my check mark. So it's 1, 5, 10, 10, 5, 1. You don't have to do that because you shouldn't have erased all that. You should still have it. So you don't have to worry about it. So 1, now I do 5. 5 x to the 4th, 2 plus 10 x to the 3rd, 2 squared. Okay. Do you think we're going to leave that 2 squared? No, we're going to simplify it. What's 2 squared? 2 times 2 is 4. Okay. Let's keep going. 10x squared, 2 cubed. Put that in your calculator if you have to, but you should know that 2 cubed is 8. 2 times 2 is 4, times 2 is 8. 8. Alright. Keep going. 5x 2 to the 4th. What's 2 to the 4th? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? And last but not least, 1 times 2 to the 5th. Do I need to put a 1 in front of there? No. Do I need to put a 1 in front of here? No. But let's simplify our 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Let's erase that and put a 32. Okay. It's starting to look a whole lot better than all that crap, right? We're getting there. One last step. I can't have a number times a number. I got to simplify that. Okay? So do I have 2 numbers in here? And not exponents, but whole numbers. No, I do not. So that just comes down. This guy, do I have 2 whole numbers? Yes, I have a 5 and a 2. And it's all being multiplied. So I just multiply those together. 5 times 2 is 10 x to the 4th. Plus, I have 2 whole numbers here, 10 and a 4. So 10 times 4 is 40 x to the 3rd. Plus, whole numbers, 10 and 8. 10 times 8 is 80 x squared. Alright, 5 times 16 is 80x. And last but not least is just 32. And that, my dear friends, is my answer. If you were to expand, I don't even remember what our first problem was. I think it was x plus 2 to the 5th power. Yes, that's what it was. Yes. X plus 2 to the 5th power. If you expanded x plus 2 to the 5th power, that's what you would get. Beautiful. Now, at the very bottom, I'm going to define a word for you. Okay? It's this, and I should have shown it to you beforehand, but I didn't. Coefficient. A coefficient is just the number in front of the letter. That's not the most mathematical term for it, but that's what we're going to say. So, what's the coefficient for this one? 10x to the 4th. 10. What's the coefficient for this term? 40. Coefficient for this term? 80. It's just a big number being multiplied times the letter. Now, what's the coefficient for this term? What's in front of that x to the 5th? It's got to be something. A 1. Okay. It's going to ask you that. It'll say, what is the coefficient for x squared? Okay. What's the coefficient for x squared? Well, you would find x squared in here. Boom. There's my x squared. What number's in front of it? 80. Okay. I think that's number 1 on your homework, actually. Okay, so that's the long way. I'm going to stop this video. It's already at 25 minutes and teach you the short way in the next video. Okay? Good luck.